Why are loops so significant in programming? Is it because they repeat a block of code until a specific condition is met? Or is it because they help in reducing the lines of code, making it more efficient and readable? The answer is both. And today, the spotlight is on one such loop in Java, the for loop. A for loop is a control flow statement that allows code to be repeatedly executed, a necessity in any programming language. The for loop in Java is incredibly versatile, giving the programmer a great deal of control over exactly how many times the loop iterates. To understand the for loop, visualize a runner on a race track. Before starting the race, the runner knows exactly how many laps they have to run. This is the basic principle behind the for loop. The loop knows exactly how many times it has to iterate over the block of code. In Java, a for loop consists of three parts: initialization, condition, and increment or decrement. Think of initialization as the starting point of the race. It's where the loop counter starts. For example, int I equals $0, where I is the loop counter starting at 0. The condition is the finish line. It's the point where the loop should stop. For example, I less than 10, where the loop should stop once I is no longer less than 10. Increment or decrement is like the runner's stride. It's how much the loop counter should change after each iteration. For example, I++ or I, where I++ means that I increases by 1 after each iteration, and I means that I decreases by 1 after each iteration. Put together, a basic for loop in Java would look like this. For int I equals $0, I less than 10, I++. This loop will run 10 times, with I starting at 0 and increasing by 1 after each iteration. This was a simple example, but Java for loops can be much more complex and versatile. They can iterate over arrays, collections, and even generate number sequences. In summary, a for loop in Java is a powerful tool that allows code to be executed a specific number of times. It consists of three parts: initialization, where the loop counter starts; condition, where the loop ends; and increment or decrement, how much the loop counter changes after each iteration. The for loop is versatile and can be used in a variety of ways, from iterating over collections to generating number sequences. Remember, like a runner on a track, a for loop knows exactly how many laps it needs to run. And with this knowledge, it can make the task of coding much more efficient and readable. So the next time you find yourself faced with a repetitive task, think of the for loop, your trusty tool in the world of Java coding.